Hi, everybody. We're going to wait a couple minutes and let people check in. We have a number of people who are just loading in their teams right now, and we'll be starting the presentation shortly. Good morning, everyone, and thank you for joining us for today's PSIA webinar, Secure Access Simplified, How PKOC is Changing the Economics of Access Control. I'm David Bunzel, the Executive Director of the Physical Security Interoperability Alliance, also known as the PSIA, and I'd like to welcome you and provide a little background on our group and the PKOC initiative. The PSIA is a global consortium of security industry leaders focused on developing open and interoperable standards that simplify system integration and improve security effectiveness. Since its founding in 2008, PSIA has advanced key specifications for video analytics, identity management, and access control, helping manufacturers, integrators, and end users advance solutions that are more flexible, cost-effective, and future-ready. One of our important recent initiatives is the Public Key Open Credential, also known as PKOC. This open standard is transforming access control by reducing dependency on proprietary systems, lowering costs, and enhancing flexibility for both integrators and end users. Today's session will share the latest updates on PKOC adoption, provide valuable design guidance, and feature insights from industry experts who are leading the transformation. I'd like to first introduce Jason Ouellette, the chairman of the PSIA, to share some perspective on what PKOC is. Jason?
Excellent. Thanks, David. And we can move to the next slide. So I think it's best to start off. I'm going to maybe even just use a bit of a story here to help explain what Public Key Open Credential is and how we got to this solution. So first, I'm going to use a fictitious company, so Sensor Technologies, that is doing the business of selling credentials, physical and mobile, to various companies. And so there are 4 companies you see down here at the bottom of the slide. And so as we advance, one thing I want to point out is I'm going to completely skip the conversation of procs and mag and all the insecure technologies. Those are out there, so we want to recognize that. But SensorNet is, tries to be responsible, so they are providing a symmetric solution, which basically means they have one secret key. That key is how they build their credentials, and anybody who uses their credentials across those 4 different companies shares that same secret. So if the sensor key is ever exposed, then the risk is total exposure for all of the credentials that they have, right? And this is really the risk of symmetric, because it is based on a shared secret, and how the cards get provisioned and how these get used out in the field requires the use of sharing this secret with those that need to be involved, whether that's a reader or a credential. We can go to the next slide. So now, realizing this is probably a risky proposition, given the attack surfaces all companies they sell their credential to, they now make an improvement, and they go to providing specific keys for each customer uniquely. It's still the same exact symmetric-based encryption, and the result of this is we now have a smaller risk, a smaller attack surface. And if we go to the next slide, what you'll see is the vulnerability just becomes the one company. That key gets exposed, it's all of their credentials that potentially then become vulnerable in the use of a shared secret. So the right away question is, symmetric, even if it is secure today, represents a risk that if it is ever hacked or that key is ever gets out to the field, then anything that's tied to that key really becomes a risk. And even in diversified is signed by a master key. And so that master key still represents vulnerability to everything downstream that is generated from it. So this is the whole of what most credentials today are based on. If we go to the next slide, then what we see is that now they've adopted moving to public key open credential and a two key solution. So there's a public and a private key, represented by red being private here and green being the public key. And so the public key is what's used physically as the credential. This is the replacement for what you would know as your badge number or credential ID. And so this is unique per credential, but it's public information, meaning it can't cause harm or theft. And if we go to the next slide, I'll explain a little bit about how that works. So like a fingerprint, what happens when the reader is receiving a public key open credential, it is going to provide a challenge from the reader back to the credential saying, prove that you have the private key for this public key that you just sent me to make an access control decision. And that challenge is signed by the credential's private key. And that way, the reader can actually validate that the source of the credential is in fact the authentic source and not a spoof. So there's nobody that can get in the middle of this and steal that, or even if somebody did know the public key, they would not be able to spoof this fingerprint validation that happens. And I use the fingerprint as an analogy. It's a it's basically validating that the private key is in fact on the credential that sent this public key. And if it's not, then it's a fake and it will not work for access control. So this really represents a much more modern way. So, the real thing that I would say is, symmetric is not a great practice. Asymmetric is the future of credentials and represents the forward-thinking, future-proof. It's agnostic to what you want to put it over with. So you can do cards with NFC, you can do Bluetooth, you could do ultra-wideband, you could do Wi-Fi, you could do whatever new communication method comes out, because what public key open credential is really a secure protocol for communicating a public key using asymmetric elliptical curve cryptography. And and so I hope this gives a more simplistic view of how it works without really getting into the bits and bytes of encryption, but proving that two keys, and where one, a private key, is never divulged or shared with anybody, meaning there is no secret, there is no vulnerability. So that's really important to understand, and the difference between what most legacy credentials are and what public key open credential can represent. And if we go to the next slide, then we see the sort of summary of this scenario where one key, shared secret, total exposure vulnerability, really not a good idea. You can do then specific keys per company, which makes the attack vector smaller, but it's the same exact vulnerability still. If that key gets out, then everything that's tied to that key then becomes exposed. So better in that you've reduced the attack vector, but you haven't solved the problem at the root. And then, of course, public key open credential, which eliminates all of that problem because it is using the public and private key pair, right? And as we said, there is no shared secret. So if we go to the next slide, then we really now answer the question. So what is public key open credential? Well, in fact, it's a modern replacement for what a credential is. And that's really, when I say simplistically, that's what PKOC is. That's really what it is. It's the modern credential. It's not trying to be other things. It's not the solution for offline. It's not trying to add other things for access control decisions. Public key open credential is a secure credential. So that's really at the definition of what I would say. And what you can see in the diagram on the right of the slide that's presenting now is the credential itself has the public and private key pair. It then talks to a reader, or PKOC can also be implemented in a controller. So that's why you see reader controller in the box below. And as soon as that credential is received, the reader or controller is going to challenge the credential and say, prove to me who you are. And it's going to either send a nonce, a random value, so it's never the same. And that also can't be spoofed because it's transactional, or it's going to, in full encryption, send its public key from the reader to be signed by the private key of the credential. And then it uses that as a fingerprint to validate that the credential actually is, that public key is the match for the private key that I'm talking to. And only in that case will we continue with an access control transaction. And this is what makes it so secure. So what are we talking about? This is all based on standards, the X509 certificates for PKI. It is, as we've discussed, a public and private key pair. And this private key is never, it's like a vault. It's never leaving that credential, whether it's mobile or physical on a card. We have the validation process, which gives us the authenticity, and we ensure the secure communications of these by using elliptical curve cryptography. One of the key differences, the next to last bullet that's here too to understand about PKOC, is that the credentials, because it's a public key, is really self-issuant. As soon as you put the credential on a card or you download a mobile app, the first thing it does is generates the public and private key pair. So there is no card management or issuance that's needed. There's an enrollment that needs to happen, right? So the credential has to get into the physical access control system, the secure print, the EV charge, the visitor management, whatever you're integrating that credential to. But the credential itself is unique. It's 256 bits. It's a very large number. It doesn't need site codes, issue codes, facility codes, or any of that other stuff. And the other important thing to understand about public key open credential is it is an open specification. There is no one company that owns or controls public key open credential. It is truly open. So with that, I think we're going to run a quick poll from the start of the presentation to now that you've heard a little bit about what this is. Do you feel like if you were asked that you could answer the question of what public key open credential is based on what we've provided? And with that, then I am going to turn this presentation next over to Rodney. You're on mute, Rodney.
I'm so sorry. So the PKOC cards that we're talking about are using a standard MS3 format. They're using the same technology that's in credit cards. So there's nothing special about the cards. They use the standard kind of technologies, and they're available from multiple sources, so you can have vendor supply chain diversity and get them get multiple implementations, so you can get diversity of the technology also. Because the cards are using standardized technology, they can be used in multi-tech environments. There are cards that do procs and something else. So you can do procs in PKOC or FIDO2 or DesFire, various things. So if you have to do a card migration project, you can issue cards that have multiple formats and then eventually turn off the more insecure versions. If you want to connect card readers doing PKOC to panels, there's several options. OSDP is the preferred one because it's secure and supervised. But there are Wiegand card readers, the USB interfaces can be used in elevator pedestals and registration situations, and there are other interfaces. And then the technology to do this, the reader technology, there are commercial products out there. There's multiple reader vendors doing it now, and there are open source implementations also. So if new vendors are trying to enter the market, there's technology reference available to do that. On the card side, these are standard JCOP cards, global platform cards. So they use a standardized interface to build applets. And so there are multiple versions of the PKOC applet from different vendors. So not only do we have diversity of sources of cards, but the, if you will, the firmware inside the card. We also have diverse sources there. Next slide. So OSDP. OSDP stands for Open Supervised Device Protocol. It's an international standard sponsored by PSIA, and its purpose is to deliver secure communications between readers and panels. So this is a mature protocol, and it can be used for PKOC credentials and many other things. Because it was designed to have device management in mind and allow people to reconfigure devices and do firmware updates, it's well suited to help a PKOC deployment or any other kind of new credential. You can, if you have appropriately flexible devices, you can install them today and then somewhere down the road update the firmware or change the credential format it's going to process. And PKOC cards are standard credentials relative to the OSDP protocol. It's just a card number. It happens to be a larger, more secure card number. There's nothing special about reading PKOC cards as opposed to anything else. And OSDP is meant as an alternative for older legacy interfaces such as Wiegand, because it adds the security capability and adding all these management capabilities. So, okay, but that's about that. On to David.
Thanks, Rodney. So as you know, PKOC will be on cards. Cards are the incumbent solution. They are legacy, and they will live for a substantially longer time. But we would also wanted to integrate Bluetooth or mobile credentials, and the choice fell on Bluetooth to provide the transport for the credentials. As Bluetooth was available in pretty much every Android and iPhone, even though NFC itself is not available on every Android phone, it is available in every iPhone. And at least the path with Apple has been with NFC is that they were not so open about allowing NFC to be used for credentials at some point, but I think it is comparatively open at this point for credential at least. The secure element on the phone allows us to store the private key securely, and we can build a secure connection from the phone to the reader. This also allows you to do firmware updates from the phone side towards the reader, in addition to having the OSDP to do that. And there are multiple PKOC compliant apps, EMSI, JCI, ELATEC, the PSIA Alliance themselves have apps available so that it could be integrated in different ecosystems or in different delivery systems as well. And Jason.
So now let's take a look at the bigger picture, right? So we've talked about what public key open credential is. We've identified that this can support legacy environments with OSDP, the fact that it's available on cards and as well mobile for iOS and Android. But when we look at the total ecosystem, what does that look like? So on the left side, we have the mobile or physical credential. Those are valid PKOC credentials using the asymmetric keys that we talked about, with the public key being the credential. The second part of this is, as we mentioned, there's no need for a credential manager or issuance because the credentials are self-issuing when the apps are installed. But now we need to get them enrolled. And so whether it be using things like, for a traditional badging station, a PKOC USB keyboard input reader, which there are several available, whether that be through EMSI, ELATEC, RFIDs, that you could then use to input a PKOC credential. But then there are more elegant solutions as well, where you may be using like a email invite that then will talk to the mobile app or to a badge reader station and be able to get the public key open credential or the public key itself, and then enroll that into whatever the various packs is using more of a web services SDK or API. So those would be a little more elegant, but you have a range of solutions. The important thing is that once you have public key open credential, then the second step is getting it enrolled. After that, people now have a valid public key open credential that can be used for access control. So you're going to interact with the reader. The reader, as I explained earlier, is going to recognize the PKOC protocol when it is PKOC compliant. It will then do that validation step that we talked about to ensure the authenticity of the credential, that it's not spoofed or stolen, using that whole public and private key exchange. And then we'll talk to the controller and the controller making the access control decision exactly as it always has. Between the reader and the controller, as Rodney pointed out, is the ability to have OSDP, especially where you may still have weakened connections, but able to now enjoy the security of PKOC and still have it encrypted all the way to the panel. And in the future, you'll see modules being available on the panels that can actually do PKOC natively at the panel, and the reader being just a pass-through. So this is what the total ecosystem looks like. So now that we've discussed that, I think the next exciting thing to talk about is the more economic aspect. And so I'm going to turn this over to Rick Focke.
Hey, Jason, thanks. Yeah, this is Rick Focke from John's Controls. And I guess I want to start off by saying that you might be asking, well, what's John's Controls doing involved in PKOC? You know, we're not really a specialist in, you know, anything, readers, credentials. We're more of a system provider, one of the largest ones. But I can say that we've had tremendous feedback from our customers that want an open, interoperable credential that doesn't break the bank. And that's why we kind of lead into the economics part of it, you know, because that is the question: how much will this thing cost? Right. So I broke it out into, you know, two different types of credentials: our historic legacy, or I guess you could say current still, plastic credential types. And as you can see, you know, the PKOC credentials are in the same ballpark as your common, you know, smart card credentials of today. You know, the MyFair cards, they can start out lower because they a lot of times come unprovisioned. Okay, PKOC cards, you know, can get a nice provisioned PKOC card in that same range, $5 up to $8. In fact, I think there's one on Amazon.com. You know, go and look. Go to Amazon, type in PKOC, and you'll, you know, maybe be surprised here. And these are ranges. You know, it depends on how much memory's on the card, what features you have. Maybe you have a mag stripe in the back that adds, you know, 50 cents onto it, or whatever. But the main point is that these cards are very affordable. Okay. Now, when you get into the mobile credential aspect of things, which the market is moving towards, it's not a majority of the market yet, but it's getting there. The ramp is pretty high. And you can see that there is a big wide range of pricing going on. I mean, you can knock yourself out with a very elaborate high-end integration, you know, with HID mobile, with even credentials. The PKOC mobile credential, if you want to just start off yourself, it's free. You generate a credential and you get it enrolled somehow in the system with like a USB enrollment device. Okay. Where the cost comes in for PKOC is you need to have, you know, more of a scalable enrollment platform. You know, if you have 1,000 cards you want to get into the PAC system, mobile credentials, you need something beyond the one-by-one, everybody march in and get your, you know, mobile phone enrolled from that USB reader. So that's where, you know, we have a, you know, $5 per, you know, per person per annual cost estimate there. But we're still working that out. There's a lot of companies that are eager to, you know, add PKOC credential support to their enrollment platform. So I think you'll see a lot of activity next year when this becomes more of a mainstream offering. Okay, so on the next slide, we just have a typical scenario. Here's a larger customer. Maybe it's a college campus. They have 10,000, you know, mobile credentials they need to get in, you know, into the system, deployed in circulation. And you can see, you know, between the min and the max of the different credentials, you know, PKOC is very affordable, you know, assuming that, you know, higher end of maybe $5 a year per credential, you know, over 10,000 credentials, right? So it's interoperable and affordable at the same time. So it's a very good solution if you're looking at a tech refresh for your credential population. Okay, so the next topic would be, well, how do I know that it's really interoperable? You know, it's going to work well with others. Okay, and that's, I believe, back to Jason on the next slide here.
Yep, thanks, Rick. So the, you know, authenticity and understanding that if you claim that public key open credential compatibility exists, how does somebody know and how are they able to trust that? So today, We do provide through our working groups the ability to submit a PKOC compliant reader or credential, whether that's card or mobile. And we test that within the working group. There are specific tools that are used for being able to look at like RF sniffers or Wireshark, or to look at the packet level and ensure that the evidence exists that the protocol is being implemented to specification. And so only the things that go through that testing end up on the website. So people can say they're PKOC compliant, they may even be, but if you want to know and trust, then we go through that process. And now we're working on the endeavor to actually make this built into our test harness, where you can self-certify and get the certificate from the device that shows compliance for PKOC. So we're continuing to evolve things to make this easier. The idea is to make adoption as easy as possible. But we also know that this is really important to people, that when they're buying something that says it's PKOC compliant, they want to be able to trust that it is in fact following by the rules. So this is something that is a core part of what PSIA is driving towards. And so now that we've said that, I think the next thing that we'd like to really share with you is some of the real world experiences of public key open credentials. So I'm going to turn this over to Jack to start.
Thanks, Jason. Yeah, so appreciate it. Thanks to everybody for the time. At LastLock, what we do is kind of self-powering intelligent access, specifically, helping champion interoperable credentials. So we have a customer in Madison, Wisconsin, Urban Land Interests, sort of a luxury property manager that has deployed PKOC throughout a number of their buildings, specifically in their co-working and flex spaces, where they see a lot of dynamic access control. They see a lot of challenges and frictions within physical key and physical fob management. And so for the last 2 years, they've been using LastLock self-powering cylinders with our software to issue free interoperable credentials based off PKOC that work across their doors, specifically their interior doors. The big challenge, across the other spaces is basically rolling out and having these credentials work in parallel. So we support the ability for them to choose, where they want their physical credentials and where they want to upgrade to PKOC, which creates, easier to manage, more affordable, and gives the customer the flexibility to work with physical credentials and then sign an upgrade to mobile access at their own speed. Next, I believe it's going on to Rick, talking about some of their applications and deployments using PKOC. Actually, excuse me,
No,
Jason.
Yeah, so it'll be me next. So just an exciting update for ELATEC. So in our Palm City, Florida office, we have now fully deployed public key open credential. This is the only means of access to the building. So we are using a Secure 9000 for the production access control, but it is implementing the full 256-bit public key open credential. And we're using the Secustos SQ80 and the Mullion MU20 readers. You see the Mullion depicted there on the screen, and that's what's sitting on those doors for the facility. We have deployed both combination of universal smart cards with the Taglio applet, the PKOC applet that's running on those cards, as well as we're using the PSIA mobile experience, and we're using both NFC and Bluetooth. So this is exciting. This happened over the last, started in September. By the beginning of October, the building was fully over to public key open credential. And we're going to continue to expand that footprint as we go to our office in Germany too. So, but really exciting progress. And next, Rick is going to give us an update.
Yeah, I'm back. And yeah, what we have here is a proof of concept in progress here for a large, financial consulting firm in Canada. Again, it's a Secret 9000 system. We're using the smaller 64-bit card number in this case, but still, the full ECC authentication that takes place. Just the last mile into the panel is 64-bit. But customer is happy so far. They have it in various readers within the building to get some use on it and kind of do some of their own internal VOC, with their employees. Like, how do you like this? Is it what you expect? Is it easy to use? And so far, it's been very good feedback. and we have plans to start rolling out across their facility footprint, with PKOC. So just some nice real world applications starting to take place now after a few years of working in the PSIA committees, getting this thing all fleshed out and getting more vendors on board. It's been exciting, and look forward to a lot of new deployments next year. So I think we're pretty much done for the slides now, David. You want to take over some Q&A?
Sure. Thanks, Rick. Yeah, we have, so everybody has the ability to put questions in the chat screen and in the chat box. So the chat box, you can click on it above and then just enter any questions. But we do have a couple of questions already. And the first one is for Rodney. What role do reader manufacturers play in ensuring interoperability with PKOC?
The reader manufacturers have to implement an appropriate protocol back to the panel. So like if they're doing OSDP, on the connection to the panel side, they're going to have to do some appropriate communication mechanism. So we prefer they do OSDP in a secure chain with the security options turned on. On the other side, talking to the credential, if they're trying to do NFC, then they're going to need to implement the appropriate commands to communicate with a PKOC card. There's public PSIA publishes the specification for that, so it's readily available for vendors and engineering teams. Same thing with the Bluetooth implementation. The specs publicly available. There are reference implementations, so the reader vendor would have to basically download the spec and code it and make sure they're running compared to the reference implementation. So we've tried to make it as reasonable as possible for vendors to adopt this.
Thanks, Rodney. This one's for David Edwin. How are PKOC-enabled apps integrated into readers and systems today?
Right. So apps work with readers, and we do have support for that. As Jason has said, in ELATEC and EMSI, so readers would support typically Bluetooth and NFC. So you could deploy whichever works for your ecosystem. So I hope that answers the question. So that's relatively straightforward. So you just check whichever readers support Bluetooth, and the apps are available on the App Store. So right now it's mainly the onboarding that has to be integrated into your ecosystem, whether it's specific to your deployment.
Okay, and I'll open it up to the group. Reader controllers that support PKOC credentials use and roll credential public keys of the individual cards for access decisions.
Yeah, I'll take that one, David. So just a little bit more on the how public key open credential works. So the public key, which is 256 bits, so it's a very, very large number. We take, depending on, like you heard Rick talk about for the experience up in Canada, they're using 64 bits or the last 8 bytes of the public key. That gets converted to a decimal value that ultimately is enrolled in the access control system. But that could be anywhere from 64 bits all the way up to 256 bits. But what you're enrolling in the access control system, in essence, is still just a large, as Rodney said earlier, a very large, more secure credential number. So that ultimately is what's being used for the access control decision, which is what makes public key open credential really easy for the PACS world, because there's nothing really different other than this is a much larger card number. And because of backwards compatibility with some controllers that can't support 256 bits, and knowing that the X portion of the public key is where all the randomization and entropy that makes the encryption robust, if we use 64 bits, that minimum number for PKOC, then we have enough uniqueness that we don't have to worry about getting duplicate card numbers or the need for issue codes, site codes, facility codes, or anything else. So that's really the answer to that question, and I hope I've addressed it well enough.
Thanks, Jason. Jack, can one credential work with multiple systems? For example, if I have a mobile credential on my phone, could it work in my office and at my gym?
Yeah. So that's the beauty about the interoperability across different elements of hardware. The specification is open. Anybody can implement it by creating a firmware and putting it on their device. And as there's more ubiquitous use of interoperable credentials. That's the value. You'll be able to take a credential with you across multiple different systems while retaining the security and privacy that both asymmetric kind of encryption allows, in addition to kind of an open architecture.
Okay, and David Edwin, can I integrate a PKOC mobile credential into my own app, and is there an SDK documentation?
Yeah, so the PSIA Alliance provides SDKs or reference implementations for iOS and Android. So the member companies also, some of them do provide, including EMSI, do provide similar SDKs. And I assume everybody who has Bluetooth support on the readers will give you SDKs so you can sort of quickly integrate it into your app and roll it out.
Thanks, David. Rodney, how does PKOC coexist with OSDP and other existing standards in the field?
So PKOC, since it's a credential standard, it only impacts the credential dialogue side of the communication. So whether you're using OSDP or not, or whether you're using Wiegand or some other, whatever standard you're using for the reader back to the panel, there's no conflict with PKOC. It does require a credential that's of a reasonable size. So if you had any kind of a standard or specification that was assuming smaller card numbers, 26-bit, like we had back in the day, then there would be a conflict there. And PKOC is a credential standard, so it's running on top of either Bluetooth or ISO standards around smart cards, and so it's coexisting with those fine. There's no special features, so it's meant to play nice relative to a standards environment.
Great, thanks, Rodney. Rick, what steps should consultants and integrators take to specify PKOC in new projects?
That's a great question. I'm glad we're getting those types of questions for forward-thinking, projects and deployments. And yeah, basically we need to, specify that the system must support those, longer, card numbers. Again, there's some older systems that they couldn't be upgraded to anything more than a 32-bit number, for example. So we are in the process of getting, more of a few-page A&E document put together, because it's not just the credential, it's the enrollments. You have to specify the USB or the enrollment platform, specify the readers. It is a system. I think there's a slide previously that Jason went forward that kind of had out had the 4 different types of devices and functions laid out there. So, but yeah, that's a good point. We'll get a separate document put together for consultants to be able to slide into an access control spec.
Thanks, Rick. And just a reminder, if anybody has any questions, you can put in the chat box, and we'll get to them as we can. Jason, what problem is PKOC solving for integrators, end users, and manufacturers?
Well, the biggest problem it's solving is security. Certainly by moving from, away from things like procs or symmetric-based credential solutions. Asymmetric is a more modern, certainly more secure, based on everything we talked about, the use of a private key that never is divulged, that is used like a fingerprint to validate every credential transaction. So security certainly is, I think, the entire chain, for manufacturers, for integrators, for consultants, for customers, a huge value proposition. But beyond that, as we heard from Rick earlier, the economics certainly makes sense. The fact that it's open, also for the integrator specifically, makes life a lot easier, right? So, I mean, as an integrator, I think a lot of opportunities come around how fast I can get in and out of sight into the next job, right? Because that certainly affects profitability. And if something is open, I'm familiar with it, and I don't need to know the 100 different card formats that I might be having to deal with at the site. And I can do this with, with one credential solution. As things evolve to that level, then you're certainly simplifying life for install, and So I think there's a tremendous amount of value that is added by what public key open credential brings to the market as a solution.
Thanks, Jason. For David and Edwin, what are the security and privacy implications of mobile credentials?
Typically, the mobile credential will be held in the secure element, so it is relatively secure. The manufacturer of the mobile ecosystem has invested in ensuring that credential or the secure element is stored securely over there, and that ensures that this transaction is held securely. So that's the main step over there. Similarly, on the reader side, there is a secure element as well. So in effect, we are able to maintain the security of the transaction on the path between Bluetooth. And of course, in a similar way, NFC is also secured as well.
Thanks, David. Rodney, what role do third-party validators or labs play in the certification process?
So in many situations, a project will want to make sure that they've got some source of information other than the vendor supply chain that a given technology is actually working. One example of this is people who have UL approved wiring. So the use of a third party testing facility or mechanism lets you have that kind of an independent voice that can make sure that everybody's implementing the product, the implementation is the same, and that there aren't any gaps that you might run into if you simply check with one vendor. This is the use of protocols across vendors. This has been going on for decades, and experience has shown that you want to make sure that you've got probably at least 3 different implementations and some kind of independent verification that the technology actually works. And the other thing about third-party validation is, if possible, we want to have the testing mechanisms for doing that are public, and that even the tools can be public. And in that way, an organization that is trying to do their own evaluation can go check that what they're trying to buy is in fact meeting the spec.
Thanks, Rodney. Jason, how does PKOC compare to Alero?
Okay, excellent question. And ironic, because I'm actually in Barcelona, Spain right now, and we just closed out the CSA's workshop on Alero. They're both based on asymmetric elliptical curve cryptography. So certainly from a modern credential and security perspective, that would be right on par. I think Alero and PKOC are both incredible moves for doing the right thing for access control and the use of credentials in general. Couple key differences that I would point out. So one, as we've mentioned here in today's presentation, public key open credential is just the credential. It's aimed to be very simple in providing a newer, more secure method of having a credential that follows the asymmetric. And it, as we talked about today, really is designed to run efficiently for both card and mobile. Alero is probably focused more mobile first. Not that it can't be done on the card, so I want to be clear about that. But it also aims to add much more capabilities. So Alero will be able to address offline use cases. It also has a higher trust chain through the use of certificates and signing. So there are definitely other advantages that Alero can bring. But the key difference is, I would say, PKOC is really probably focused more to be beneficial on card, and as well the simplicity of just being the modern replacement for credential without all the complexity of trying to solve other things that many enterprise solutions and offline devices are going to need. So I don't really look at them as a lot of times people ask me is what's going to win? Is it going to be PKOC? Is it going to be Alero? I don't see it that way at all. I don't even think that's a right question. I think they solve different problems, and they both have a great place in the future of the access control industry. You're on mute, David.
Sorry. Question for Jack. What lessons have emerged from early PKOC rollouts?
Oh, that's a great question. User education is really big in terms of the experience being very similar. You know, you tap a fob or press a button and light goes green. That's what really most people care about. But understanding the underlying technology about why it's different and better is important, as well as the cost perspective. On the development side, a lot of learning lessons for the working group and for the team in general, basically how to accelerate the development and deployment of a new technology across a lot of different companies effectively. This is where it comes to working together, providing a specification, providing open source code in order to accelerate development and deployment. And how to do that is constantly evolving and maturing. Yeah, I think those are kind of the two big learning lessons, at least myself and LastLock has taken away from this initiative.
Thanks, Jack. Last question for Jason. What are the considerations and costs for migration from CS to PKOC for enterprise systems? Current system contains HID CS, iStar panel, Secure 9000, about 70,000 users.
Yep. So, certainly there's a lot of considerations that need to be taken into account, and it starts with if you're trying to move to a public key open credential environment, then you've got to think about how to move from where you are, and certainly migration is a key thing to think about, but there are licenses and requirements to make sure things are done the right way. In particular, if HID technology is being used, having a reader that can read PKOC and HID technology simultaneously certainly has fairly stringent requirements, and so those cost factors need to be taken into account because it can't just be any reader. Multi-credential use, so you could also start migrations by using cards like from universal smart cards that have the multiple technologies on it, and start by providing those to all of the users, and then whether they go to a legacy reader or a newer reader, so now you can phase the readers more economically over time. So those are certainly considerations that need to be taken into place. And the last one that I would say is what Rick touched on earlier, which is enrollment. So, regardless, at some point, the public key open credentials need to be enrolled, and the question is, how do you want to do that? And there are some really elegant solutions which can be higher cost, or there are more simplistic solutions like using just a USB badging station to get the PKOC credential enrolled into a system. So, or you could even potentially use things like import and export if you're buying bulk of them. So there are definitely a number of options. Those are all things that I think you need to consider when you think about how you're going to move from where you are to where you want to be, having a more secure and more future-proof state.
Thanks, Jason. All right, and wrapping up, I'd like to thank everybody for taking the time to join. I'm impressed that everybody felt inclined to just stick with us and listen to all the information that we provided. The video will be available on the PSIA website of this for any of your colleagues who maybe would like to hear this but weren't able to join. We also would encourage the various companies who are not part of the process to join the PSIA in our discussion. If you want to make or have an influence on the specification and its development, contact us and we can help you find out the best way to do that. So if anybody has any other questions, feel free to email us, and I'd be more than happy to direct it to the proper person. Our panel would be available to answer any of the questions that you didn't get answered on this. Once again, thank you for joining us, and we look forward to talking to you again soon.